this is our lesson on problem solving with the area of a circle. So to get our minds warmed up, could you have a quick go at these starter questions and pause the video like we always do, have a go and then come back and play it to check your answers. Okay, so the answer to question 1 is the formula to calculate the area of a circle. So that's A equals pi r squared. And we know that from last lesson that we looked at this in a formula triangle. So A on the top and pi r squared have to be along the bottom line because these are touching, which means timesing. So these are both touching and timesing on the bottom there. Question 2, the radius it tells us is 10 centimetres. And we're asked to find the area. So if we look at the formula triangle we've just done, area is equal to pi times r squared. So we substitute that in. We know that 10 squared is 100. We write it first of all in terms of pi here, and then we type it into our calculator to give us 314 centimetres squared gives area, and we always round to 3SF unless it says otherwise. Number 3 is slightly different because it's told us it's given us the diameter. So therefore we've got to find the radius first, which is half of the diameter, or the diameter divided by 2. So 8 over 2 gives us 4, and then we carry on exactly as we did with question 2. So here we go, area is pi times the radius squared, 4 squared is 16, and that comes out as 50.3 centimetres squared. Now the challenge, finding the area of a semicircle, this is more of the problem solving that we're going to be doing today. So I'll put the working up here and you can copy it down if you like, but then we'll talk through the process more in the following examples. Okay, so rather than just doing pi r squared for a semicircle, because it's half of a circle, we do half times pi r squared, and then all of our working follows as normal. Okay, so problem number 1, calculating the area of the semicircle. So this is looking at that same procedure we just saw in the starter activity. So a semicircle is half of a circle, so rather than it being area equaling pi r squared, it's the area equaling half of pi r squared. So we'll start off by writing that formula out. And then we'll see what information we've got so far. So we're given this measurement of 9 centimetres, which is from one side of the circle all the way to the other. And that makes this the diameter. And therefore, the radius is the diameter divided by 2. And I'm going to leave it as 9 over 2, just because I find fractions easier to work with than decimals. So we're then going to say that its area equals a half pi times the radius, which is 9 over 2 squared. Okay, now remember we try and be able to do things in terms of pi, because there might be a point in the future where we're asked to do this without a calculator and leave our answer in terms of pi. So far we've got a half times pi times, and then we've got 9 over 2 squared. And to work this out, we simply square the numerator, the top, and then we square the denominator, which is the bottom. So 9 squared is 81, and 2 squared is 4. Then we do our multiplying of fractions. We notice that we've got pi by itself, so that's an invisible over 1 there. So we've got 1 times pi times 81, which is just 81 pi. Then on the bottom, the denominator, we've got 2 times 1 times 4, which is 8. So here we are, we've actually got an answer here in terms of pi. So we haven't touched a calculator at any point up to this, but we will pick one up now, and 81 pi divided by 8 gives us a final answer of 31.8 centimetres squared, correct to 3 significant figures. Now, you wouldn't be wrong if you'd said that the radius was 4.5 all the way back here and worked with 4.5, but working with fractions just makes the squaring part that little bit simpler without a calculator. Okay, problem 2. So this one's a quarter circle, and we dealt with a semicircle and a quarter circle when we were doing circumference, so we're a little bit used to this now. So a quarter circle is going to be simply a quarter of the whole area if it was a full circle. So we're going to have that the area is 1/4 of pi r squared. Now, the measurement that's given to us this time is 9 centimetres, but it represents a different part of the circle. We've got to imagine that this is the full circle here, and the quarter is just one part of it. And therefore, just here is the centre of the circle, which makes this measurement here the radius. So it might just be worth labelling that on the diagram. And then we'll go ahead with our working. So area equals a quarter times pi times the radius squared, which is a quarter times pi, and 9 squared is 81. Then we're multiplying with fractions, so anything without a denominator has an invisible denominator of 1. Multiplying the numerators together gives us 81 pi. Multiplying the denominators together, 4 times 1 times 1, gives us 4. And again, here is our answer in terms of pi. And we pick up our calculator for the very final stage. And that gives us 63.6 centimetres squared, correct to 3 significant figures. It's worth you typing all of these into your calculator yourself at this point as well, just to make sure that you're using your calculator correctly and getting the same answer that we have in the example. Okay, last question here then. This one's a little bit different. So we've got a semicircle inside a rectangle, and you can see that the semicircle is touching right up at that edge here. It touches perfectly at the top and it touches perfectly at the edge as well. And we're finding the shaded area, so this grey section here. So overall, what we can be thinking of doing, we could work out the area of that full rectangle, and then we could work out the area of the semicircle, and then we could take that semicircle away from the rectangle, which would just leave the grey parts there. So that's our general technique for this question. But we're missing a couple of measurements at the moment. So we just want to look at the diagram. Obviously this rectangle is 8 centimetres wide, we can see that, but we don't know how tall it is. The 8 centimetres does represent something on the semicircle though as well, and that's the diameter, because it's going all the way across from one side to the other. So if 8 centimetres is the diameter, we know we can work out the radius from that. We can just half it to get the radius. And if we look just here, because that's the centre of our circle, that distance there would be a radius, because it would be going from the centre. If we imagine that this is our full circle, and there's the centre, that distance there would be the radius. So, given that the diameter is 8, we know that that distance, which is the radius, is 4. And that's doubly handy, because now we know the height of the rectangle as well. So, I'm going to start off with the area of the rectangle, and I'm going to write A, and then I'm going to put subscript rectangle there. We're working with 2 areas this time, so we want to mention which which area we're working out. The formula for the area of a rectangle we know is base times height. So the base is 8, the height is 4, and that gives me 32 centimetres squared. Okay, now I can do the area of the semicircle, and we've just done that where we saw that it's a half times pi r squared. So that's the same as a half pi, and we just worked out the radius is 4, and then that's squared. And I'm just running a little short of space here, so let's think about the fact that 4 squared is 16, half of that is 8, so then we've got 8 pi centimetres squared for the semicircle. Now what we've done so far with the area of a semicircle or a circle or a quarter circle is we've then put this into our calculator, but this time the area of the semicircle is not the final answer that I'm looking for, so I'm going to leave it in terms of pi because I know that that's exact. So I only round when I know I'm right at the end of my calculation. So I'm going to use it just with 8 pi for now, and I'm going to now work out the area of the shaded section, which we talked about was the rectangle minus the semicircle. So the rectangle is 32, the semicircle is 8 pi. So again, this line of working is in terms of pi, so that all of this has been done without a calculator, and only for the very last line do I type that in, 32 minus 8 pi, and that gives me 6.87 centimetres squared, correct to 3 significant figures. Great work!